Hi, this is the demo of our project. Our team designed a snake game based on FPGA. The snake's movement is controlled by 4 buttons, and the resize is controlled by the rightmost switch. Users can also use 3 switches to choose the level of difficulty. If we choose the hard level, the snake will move very fast, and in the easy level, the snake moves very slowly, just like this. I will use the easy level to demo our work. When the button is pressed, the system first determines the current direction of the snake. If the press direction is different from the snake's current direction, the snake's movement direction will change accordingly. For example, pressing the right button will make the snake turn right, but if the snake is already moving to the right, pressing the right button will have no effect. After the snake is able, it will become longer, but the maximum length we set is 10 to make the code easy. We also designed to use FPGA board to display the score. Unluckily, we faced some problems so that the score could not be displayed correctly. Moreover, we can use the switch to pause the game. If we toggle the switch again, the game will continue just like this. We have 5 parts for our design. They are the clock division, VGA display, snake movement, keyboard interface, and score display part. Our first 3 modules successfully meet our need. However, we faced problems in the last 2 parts. In the beginning, we planned to use PS2 keyboard for FPGA so that users could easily use the keyboard to play our snake game. Well, we finally failed in this part since the signal could not be received properly. We finally revised our code to use FPGA button to directly control the snake movement. For the future improvement, we kept these 2 modules for keyboard interface instead of directly deleting them. For the score display, just like what I mentioned in the demo, it cannot display the number correctly. Since the code is complex, instead of dividing up parts, we do and revise the whole project together. Then, I will explain the code of each module. The first one is a clock division module. It divides a high-frequency input clock to generate a slower clock signal. It uses a 22-bit counter that counts up to 4 million cycles and then resets. The output is derived from the second least significant bit of the counter, toggling every time the counter overflows. The second one is the VGA display. The VGA module generates the timing signals for a VGA display. It takes the 25 Hz clock and produces horizontal sync, vertical sync, horizontal counter, vertical counter, and a video on signal. The module defines parameters for pixel-wise, line count, and sync front and back push timings. It uses counters to track horizontal and vertical positions, adjusting the sync signals accordingly. When the counters are within the visible area, defined by the front or back pushes, the video signal is active, indicating when to display video. The third one is snake module. This part is complex since it includes several logic. The key logic includes difficulty selection, direction control, movement and growth, collision detection, full generation, and state transitions. In the difficulty selection part, it occurs in state 0, which is the game initialization, and it is based on the key pressed by the user. The key out input is checked to determine which difficulty level the user selects, easy, medium, or hard. The selected difficulty adjusts the snake's speed, making the game more challenging or easier depending on the choice. In the direction control part, the direction of the snake is controlled by key out, and the snake cannot move in the opposite direction. The snake starts by moving left and can change direction based on key presses, but now we use buttons to control that. And in the movement and growth part, the snake's movement is managed by updating the positions stored in HR and VR, representing the body segments. The snake grows when it is full, and the num tracks the length of the snake. In the collision detection, the game checks for collision between the snake's body and the walls using eye shade and eye shade 1. If the snake collides with itself or the walls, the game transitions to stage 3, which is a game over. And in the full generation part, the foot's position is randomly generated using random X and random Y. If the snake is the foot flag is set to 0. It indicates that the foot needs to be refreshed, and the snake grows in lines. Moreover, if the foot overlaps with the snake's body, the eat flag is also set to 1, indicating that the snake has eaten the food. Then food flag is set to 0, signaling that the new food needs to be generated. However, in these situations, the snake will not be longer. And this part also includes state transitions logic. The game transitions through states based on user's input and collisions. From state 0 to state 1, state 0 means initialization and state 1 means setup. It is after difficulty selection. And from state 1 to state 2, which means game running, it is after setup. And from state 2 to state 3, which means game over, it happens on collisions. Stage 3 allows the players to restart the game by pressing a key. U4 and U5 are PS2 keyboard part, and in the keyboard module, this module simply processes the movement direction keys and assigns a value to KB out depending on which key is pressed. It was used to transfer PS2 keyboard signal to FPGA, but since we failed in this part, we delete it in the demo. Instead of it, we add input move into the keyboard module to directly control the snake's movement using buttons. And for the keying modules, this module handles debouncing and key price detection, ensuring that only valid key prices are processed. It outputs a decoded value, key out, based on which key is pressed from the 5-bit key input. U6 is the scoring part. We also failed in this part. The scoring module should take the score as input and display it. It breaks the score into 100 tens and 1 digit user counter. And based on current digit, the correct 7-segment pattern is selected and displayed on the appropriate digit, but we don't know why. But it cannot display the correct number.